No matter how TV is routed into your house, one thing that can be a real problem is getting that TV signal to every single room. Sure, you can run wires all over the house to cable up every room and split the signal between them, but that could compromise on quality, not to mention all of the inconvenience around all of the work that you have to do, the damage that you have to do to walls and stuff, and the mess that you'll make as a result. An alternative is to use IPTV, where you can use your existing home network to move TV signals around each room. And you can do this using a Raspberry Pi. Let me show you how. Hello once again, Pi geeks and techno nerds all around the world. My name's Jeff, and I'm an IT professional who's been in the industry for over 30 years. In my spare time, I like nothing more than playing around with Raspberry Pis, and I'm sure you do too. If you like what you see here, please click that thumbs up button, subscribe if you want to see more, and hit that notification bell so you can be told when I put a new video out. And let me know in the comments what you think about this video, and also, if you've got any ideas of other projects that you'd like to see me take on, make a note in there too. Here where I live in the UK, I've got really two choices when it comes to receiving TV. I can either use digital terrestrial TV, where it's received via an aerial on the roof, or I can use satellite TV. Now my aerial on the roof is really old, and it doesn't really work with digital TV. I don't really want to go through the expense of having it swapped out. So when I first moved in here, I actually chose to get satellite TV, and I took this from a company called Sky. They installed a dish on my house that had a wideband LNB on it. This had two outputs for horizontal and vertical polarity, and these were taken into the living room of my house. Now this is in the lower floor of the house, and you can see this coming in here on the right hand side. Now I do have one TV in the living room, so I was able to watch TV there just fine. However, I've got three other rooms upstairs, and each of those have TVs in them as well. So in order to get my TV signal up to there, I actually had a choice. I could either spend a whole lot of hassle trenching into walls, running cables throughout, making a complete mess and probably breaking a load of stuff. Or I could make use of what's called IPTV. Now what happens here is that you have a centralized tuner somewhere in your house, and then this takes the TV signal and it makes that available over your home network. So any streaming devices can then pick it up and show it on any TV in the house. Now this is really useful for a number of reasons. First off, there's the obvious, there's no limit as to how many rooms in the house I can route this to. Secondly, I can centralize any DVR functionality. Any recordings I make from the tuner can then be accessible by anybody. Thirdly, there's no wiring necessary. I've got a really good wireless network here based around Wi-Fi 6. But to be honest, as long as you're not running a really old 2.4 gigahertz wireless network through your house, your home network will be able to carry all of these signals absolutely no problem. Lastly, in order to receive these signals and actually play them onto a TV, you can use commodity devices for this. This could be any kind of smart TV, or one of the streaming devices you can pick up, be it Google TV, Chromecast device, a Fire TV stick from Amazon, or a Roku device. All will work absolutely just fine. You just got to find the right app for it. So let's take a look at what we need to put all of this together. The first piece of kit that you need for this is something to tune into the TV signals. Now you can use one of these. It's a little USB terrestrial TV tuner, and this will work just fine if you get your TV signals from an aerial on the roof. You just plug your aerial cable right into the back of it, and then the other end into a Raspberry Pi. You can then use the application, I'll show you in a little bit, to tune into the signal and make that available across your network. Now for my case, I need something a bit more substantial because I've got satellite TV. Now I mentioned earlier that I had Sky TV. Now their service got a little bit expensive for me, so I cancelled that some time ago and I switched to using a service called FreeSat instead. This allows you to get a satellite receiver of your choice as long as it's capable of receiving the signals, and then there are a whole bunch of channels that are transmitted free to air that you can receive over it. So in order to receive these for my IPTV project, I had to get a satellite receiver that was capable of turning those TV signals into IP. And that's where this comes in. It's made by Telestar and it's called a Digibit R1. Now this is a satellite receiver that's actually got 4 tuners built into it. You connect your satellite cables straight into the back of it in the connectors that you can see on the left. And then there's a LAN port on the right where you can connect it into your home network. And also you'll notice there's no HDMI port or anything like that on this. It can't actually output the TV pictures directly to a TV. This is purely for IP. Now if we take a careful look at the LNB connections, you can see that they're labelled up as HH, VH, HL and VL. And this is quite different to what was provided by my old Sky satellite dish. This only had 2 cables provided with it, one called V and one called H, representing the different signal polarities. The Digibit R1 uses what's called a Quattro interface, whereas the dish I have uses what's called a wideband connector. So I had to get one of these. It's a wideband to Quattro converter. I can connect my cables from my satellite dish straight into the top to the V and the H signals, and then I've got all of those 4 signals that the Digibit R1 requires on the bottom. The next thing you need is our favourite piece, a Raspberry Pi. In my case, I'm using a Raspberry Pi 4 for this, but feasibly you could use anything from a Raspberry Pi 3 upwards, although I'd recommend using a Pi 4 because it's got gigabit networking. Since it's not particularly stressful on the CPU or memory, a Pi 5 would probably be overkill, but it would run on there just fine. Now, in addition to the Raspberry Pi, you may want to get a USB 3 external SSD, and you could then use this to store recordings from your IPTV setup. But that's entirely up to you. It's not mandatory. I personally find that I use streaming services like iPlayer or ITVX quite a lot for watching TV on demand. I don't find myself actually recording that much anymore. Now, the last thing you'll need for this project is something to view the actual TV signals. Now, most smart TVs will support this no problem, but you'll normally need to install an extra app. The ones that I'm going to show you later are specifically supported on Google TV or Android TV devices and on Amazon Fire TV sticks. I've not done a lot of testing around Roku's, and obviously different smart TV models will have their own app systems. So you may need to hunt around a bit, but hopefully you can find something that supports IPTV. Now, as I mentioned before, the aerial on my house isn't very good, and so I'm not going to be able to use a regular terrestrial TV signal in the rest of this video. It's going to be specifically geared towards my satellite TV setup. However, when we get to installing the software on the Raspberry Pi and you see how that connects to the tuner, a lot of that applies just as much to a terrestrial TV tuner as it does to my satellite TV tuner. They both fundamentally work in the same way. But as a start, let's go and set up the satellite TV tuner. When you first fire up the Digibit R1, it doesn't have any display on the front, and so you've no idea what its IP address is. However, you can normally find that out from your router. But when you do have that, then you can just open up a browser and navigate to its configuration page. Now, you could potentially only use this device to watch your TV all around the house, but it's actually really cumbersome. And so we'll make that a lot easier by using the Pi in a little bit. But for now, let's just take a look at the basic functionality that this thing offers. There's a channel search facility, and in here you can pick what satellite you're connected to. In my case, I'm connected to the Astra 2E satellite at 28.2 degrees. I can then say that I want to do a quick scan for all free-to-air channels and just start a search. Now that's complete, you can see it's been able to find 720 TV channels and 140 radio channels. And all of these are free to air. Now this is way more than you would normally find on Freesat or on Sky. So why is it? Well, the reason is that there are actually many TV companies that use this satellite and transmit their TV stations over it. Sky and Freesat are only one. Now, because this particular satellite receiver isn't bound to either of those companies, we can actually see every TV station that is available to us. Now, you can see on this page that it's actually been able to pick up an awful lot of TV channels in a whole bunch of different languages. And that's from all of these different TV networks. Now, not all are going to be relevant to me, so we're going to be doing some filtering later on. But you can see from this that the tuner is really effective and does an amazing job. But now let's go and take a look at the Raspberry Pi and get some software installed on there that we can use to hook into these TV services. Now, as I mentioned earlier, I'm using a Raspberry Pi 4 for this, and I've used Raspberry Pi Imager to install the 64-bit Lite version of Raspberry Pi OS onto it. Now, if you're not familiar with how to do that, then you can take a look at my video on how to do that right here. It will take you through step by step the whole process to get the operating system installed. It's really easy. But once you've got it installed, you can log into it via SSH and you'll end up at this kind of terminal. Now, the first thing we want to do here is install Docker and Docker Compose. So I'm going to do that with these commands. I've had this pop-up appear here. It's no big deal, just hit OK. Now, the next thing I need to do is enable this user to be able to use Docker, and I can do that with this command. Once that's done, I then need to log out and log in again. Now that's complete, I can just prove that Docker is running by running this. Now, in order to help you out here, I've put some scripts available on my GitHub that you can use to set up the software. You can clone the repository with this command. Now we have that, you just move into the IPTV directory. Then I have 3 files in here. The README is just documentation. The IPTV.yaml file just provides configuration for Docker Compose in order to run up the application. The setup.sh script is used to prepare the system for running the necessary software. So let's run that now. Now we've got that done, let's take a look at that IPTV.yaml file. Now, for this project, we're going to be using a piece of software that's called TVHEADEND. And this application is specifically for spreading IPTV around your house. The image line defines what Docker container we're going to run. We then just give that container a name that we can refer to it as. Now, this particular container needs some environment variables to be set up to provide some configuration information. Here, we're giving it a user ID, a group ID, and a time zone to run against. All other configuration is optional, and so we're not specifying anything else. We then define 2 directories on the box that we're going to map through to the container. The data directory will contain all of the configuration for TVHEADEND, so if we reboot the Raspberry Pi, we won't lose anything. The recordings directory is used to store any DVR recordings that we make from our TV signals. Again, we map those onto the Raspberry Pi itself so that they can persist in case we do reboot the Pi or stop and start the container. Now, I'm running this container in host network mode. This is definitely not best practice. What you should really do here is define ports that you want to be exposed onto the host layer. It's way more secure that way. However, in this particular case, it can get quite complex, especially with some of the UDP connections that are coming into the container from all of your devices. So using host network mode is just easier. The final line just tells Docker Compose that if the container stops for any reason, unless it was specifically stopped by the user, that it should always try to restart it. This way, our container should always run, even after a reboot. Now we understand all of this, we can just go ahead and run the thing up. Now that's running, we can see it in the background. Now we need to go and take a look at its web interface so we can actually configure it. Now, when we first run TVHEADEND, there's not an awful lot to see. And the user interface isn't particularly easy to use. It's certainly quirky, but I'll show you how to get around it. The first thing you want to go to is the configuration tab. And in this general section here, we want to set up some basic configuration options for the user interface itself. Firstly, I want to set the default language to English, but set it for whatever's relevant for you. And then for the default view level, I'm going to make that expert. This makes a lot more options visible on a lot of the different pages and will be a lot more useful to us. For the EPG settings, I'm going to make the default language again English by double clicking on it. I then just need to click the Save button. Once that's done, I want to go back into configuration, and this time I want to move to the users directory. We need to create a new user here that our various devices can use to connect back to this TV headend instance. So I'm going to hit the Add button, and I'm going to put in as a username IPTV. For its parameters, I'm then going to check all of the first few boxes. So rights, channel number range, channel tags, DVR configurations, and streaming profiles. Everything below there you can leave unticked. I then want to check the link for the web interface. And then under streaming, I want to check all options. So basic, advanced, and HTSP. For video recorder, I want to again check basic, HTSP, view all, manage all, and failed view. Under streaming profiles, I want to again check all options. This means that whatever device we connect will use the best streaming protocol available to it, given those options. And in DVR configuration profiles, I just want to check default profile. Once we have all of that set, I'll just scroll to the bottom and click Apply. Now you can see a new row has appeared in the UI here, so I don't actually need to hit the Save button or anything else. I can just click Cancel now. The next thing is to set a password for that new user. And for this, you have to go into the Passwords tab, hit Add, provide the username, in our case IPTV, and then provide a password for it. In my case, I'll make that simple and IPTV again. For persistent authentication, I'm going to say Enable. This will prevent the devices having to re-authenticate over and over and over again. After this, I just have to hit Apply, hit OK, and then Cancel. After this, in configuration, I want to go to DVB Inputs. And the first thing I want to do here is go to the Network tab, and I want to add a new network. Now, a network in this context is effectively analogous to something like a TV service. If you drop down the options, you can see available are all horrible looking technical terms. However, if you're using a digital terrestrial television system in the UK or in Europe, select DVB-T. If you're using a digital terrestrial TV system in America, use ATSC-T. If you're using a satellite system, then use DVB-S. Now, where I'm using satellite TV, that's what I need to select. I then want to mark this as enabled and then just give it a name. In my case, I'm just going to call it Astra, as that's the satellite that we're using. It then has a box for these predefined muxes. Now, a mux, or a multiplexer, is a collection of channels at a specific frequency. Now, as we saw on the Digibit earlier, it was able to find hundreds and hundreds and hundreds of TV channels, and we want to restrict that to only the ones that we're interested in here. So I'm going to limit this to the 28.2 East Astra satellite, and then under orbital position, I'm going to make that 28.2 degrees east. I then just click Apply, OK, and Cancel. We now need to apply this network to all of our tuners. So if I go to TV adapters, you can see from my Digibit R1, I've got 4 separate tuners, and each of those have 4 different satellite positions. These represent those 4 different LNB connections on the back of the box. Now, for each one of these, I need to click on it, I need to enable it, and I need to assign it to a network. And then hit Save. And I need to do that for all of these 16 connections. So I'm going to do that and then come back when I'm finished. Okay, now I have all of those complete. The next change I want to make is under the Muxes tab. Now this shows all of those default multiplexers that we selected earlier. First thing I want to do is show all of these. So in the drop down in the bottom right hand corner, I'm just going to select all. I'm then just going to select the first row and then hit Control A to select everything. And then hit Edit. Now there are 2 major satellite protocols that we can tune to here, DVB-S and DVB-S2. Most modern satellite systems use DVB-S2 these days. Some still use DVB-S. It can be used for some of the metadata services like electronic program guides. But in this case, I want to select DVB-S2 for everything. And I then apply that and save it. The next thing I want to change is in the Channel EPG tab, and I want to go to EPG Grabber modules. Now these are modules that are used to scan for electronic program guides, and you need to make sure you've got the right one selected. In my case, I'm not actually going to use the FreeSat one, but I'm going to use the Sky one instead. And the reason will become clear once I've done all the actual tuning, so please just bear with me. However, I need to disable the default ones. So I just click on it, hit enable to clear the box, and then hit save. And then repeat that with the other one that's enabled by default. I then want to take the OpenTV Sky UK module, and I want to enable that and save it. Now we've got all of that done, we're actually ready to start scanning for channels. I need to go back to the DVB inputs page and TV adapters. And now I can enable each one of my tuners. I do that by clicking the actual tuner entry as opposed to the position entries that we used before. Enable that and then hit save. And what you'll see there is because networks are configured for all of our different positions, they all get bolded, and then the tuner itself gets bolded, and all of this shows that it's enabled and working. So I'm now going to just repeat that for the other three tuners. Now if I go back to the Networks tab, enabling those tuners will have kicked off a scan across all of those multiplexers. The last column you can see here reflects the current status. So in this case, you can see the numbers changing quite a lot. Along the way, it will pick up new muxes that it wasn't aware of before. So you'll see the number occasionally jump up, but across the entirety of the scan, it will gradually decrease to 0. So I'm just going to leave that alone and let it do its thing. Here, you can see that the scan has almost completed, but it's saying there's still 2 left to go. Now it's been stuck in this state for some time. I think it has probably just got stuck. Sometimes this can happen. The way to get around this is if you go back to the muxes tab, change the bottom right hand corner so that all entries are shown, and then sort the muxes by scan result. Here you can see that there are 2 active scans still going on. If we select both of those and hit edit, then we can check scan status and set them back into an idle state. And if we apply that, then they will go back to an idle state. If we now push them back into an active state, that will cause them to rescan again. And hopefully this time they'll complete okay. And indeed, now it's dropped to 0. So we've been left with 950 channels that the scan has been able to find. Now a lot of these channels won't be relevant to us. Most of them will actually be encrypted, and so we can't watch them even if we wanted to. So what we need to do is actually find out a channel grouping that can only contain the channels that we're interested in. So here I need to do 2 things. The first thing I need to do is go back into the muxes page, change the view so that everything is shown, and then I'm going to sort by the name column. So this sorts by the satellite frequency. I'm then going to find the frequency 11778. And you can see there are 2 entries for it here. One has failed, one is okay. I'm going to take the one that's okay, and I'm going to double click on it. And I'm going to set its EPG module to be that OpenTV Sky UK module that we selected earlier. And then I'm going to change its EPG scan to be auto detected. And then I'm going to save those changes. I'm then going to go to the Channel EPG tab and then down to the Bouquets tab. Now bouquets are effectively collections of channels that are defined by different providers. Now here on this Astra satellite, you can see there are tons and tons and tons of bouquets that have been defined by Sky. If I select all here, then there's over 370 available, and they go on for ages. But eventually you get to this section where there's all of these HD England bouquets available. If I just extend that out just a little bit so we can see all the text. Here you can see they're split by region. And here I just want to select the region that I'm in. Now I'm specifically going to pick this B Sky B Bouquet 5 for this. And the reason is I've found that gives me the best balance of channels for my use. But if you wanted to experiment around with these, please go right ahead. This just worked for me. Now if I select that, you can see in the channel mapping options, there's an option here for map encrypted services. And I don't want to do that. So I'm going to double click on that, hit the drop down, and then make sure that is not selected. I'm then going to hit the enabled checkbox to enable that particular bouquet, and I'm going to hit save. Now the one thing I need to be very careful about here is making a note of this frequency over in the right hand side, in this case 11052.75H. This is the frequency of that bouquet, and I need that to be rescanned now. Now, just so we can see what happens, I'm also going to check this little pop-up box down in the right-hand corner, because this will show us the log output from TVHEADEND, and it will make a bit more sense as to what's going on if we keep an eye on that. So now I need to go back to DVB inputs and muxes, and I want to find that 11052 frequency. 11052.75H. I want to select that and I want to rescan it. So I'm just going to double click on scan status. I'm going to make that active and then I'm going to save that. And that will force that mux to then get rescanned again. And as that happens, you can see in the logs here, it's actually mapped a list of all of the channels that it found from its original scan against the bouquet that we defined earlier. And what this has actually done is it's given us a list of available channels. So if I go to the Channel EPG tab and then select Channels, we can see here that we've got a load of channels defined, but they have all of their names in there and they have their proper channel numbers. Now all of these are also free-to-air TV channels. All of the encrypted stuff is all filtered out. So this is really, really useful. And you can see here that we've got 290 channels mapped. Now this is why I like to use this particular B Sky B bouquet rather than the actual FreeSat one. With the FreeSat bouquet, I end up with about 170 services. And that's good, but obviously the more I can get, the better. And since these are all free-to-air channels, I just figure why not? The more the better. So now the last thing we need to get is all of the electronic program guide for all of these channels. And the way we do that is by going back to DVB inputs, back to our muxes, again make sure that everything is shown, and we'll go back to our 11778V frequency. And again, if I select that, change its scan status to active, then we can force a scan of that. Now we've got that done, we can go back to our Channels EPG tab and EPG Grabber. Now there are two different ways that this EPG Grabber can work. One is that it can run against some external EPG source like XML TV, or we can pick up over-the-air EPG information. Now I want to scroll down a bit to the over-the-air settings, and I want to change the default timeout for this. It normally gives it 600 seconds to complete. I'm actually going to give it an hour because sometimes this can take a really long time to work. I'm going to hit save on that. I'm going to trigger the over-the-air EPG Grabber. And you can see in the log, this has now kicked off an EPG grab process. And we can look at that in the status tab. And we can see now that that is grabbing all of this EPG data from the satellite. And it's running at a really high pace. This is over 18 megabits per second. If we look at electronic program guide, then we can see it's starting to get all of this information and it's starting to present it to us. So now TVHEADEND knows all about the channels it's able to serve out and the electronic program guide. The next step is to set up our actual client system so we can watch the TV. So let's move on to that. Now we need something that we can use to actually watch these TV channels. Now what I'm going to use for this is my Raspberry Pi based Android TV box. If you haven't seen the video where I put this together, you can find this just here and it will take you through the process. Once it's all complete, you've got a fully working Android TV system that you can just plug into your TV. The user interface for it when it's all finished kind of looks like this. Now what I'm going to do here is install a new application called Tivimate. So I'm going to go to the Google Play Store. I'm going to go up to the search options and I'm going to just search for Tivimate. It's T-I-V-I Mate. You can see it's found it there. So I'm just going to go ahead and install it. Okay, now that's installed, I'm going to open it up. We need to allow it to open up over the top of other TV services, so we can do that. And now we need to add the playlist that TVHeadEnd provides. For our case, this is an M3U playlist, and we can enter the URL. Now the URL consists of http:// and then the IP address of our TVHeadEnd server, then have to put in a colon and the port number for our TVHeadEnd, and that's 9981, then /playlist/channels. And we can then just hit next. That says that it's given us 290 channels, so we hit next. And then we want the EPG URL, and again, TVHeadEnd can give that to us. Again, starts with http:// and the IP address of our TVHeadEnd server. Then the port number. Then we want to put in /XMLTV/channels. Now this will take a little bit of time for it to process all of that EPG information, so I'll come back when that's done. Okay, here you can see that it's picked up a lot of the current programs that are on, and indeed, if I select one, I can actually start playing it. Now I won't play this for very long because I don't want to get a copyright strike, but if I go all the way down here, then I can get to the Sky intro channel. And this just plays a small video showing about the Sky service. So that should keep me away from copyright. But you can see it's playing the TV absolutely fine, and I can play any channel I want from the list that's in the guide. So this is working really, really nicely. Now with this Tivimate application, I'm not actually sure about its licensing. When you go to the website, it actually seems quite complicated, but for a simple setup like this where you're using your own playlist from your own TVHeadEnd server, as long as you're not using multiple playlists, then it seems to be perfectly fine and should allow you to do that for free. But let me show you one other application that I've actually purchased that works in a similar way, but it's just got a slightly different interface to it. The other application I use for this is called Dream Player. So let's go and find that. Now there are a bunch of different versions of this software available. You need to get the one that's designed to work against TVHeadEnd. And so I'm just going to go ahead and install that. Now that's installed, I'll just open it up. So I'll just click on Next. Now here they've got their own privacy policy and application policy. So yeah, I'll say I accept that. The first bit of configuration it needs is the actual TVHeadEnd server itself. Now I had this installed previously, so it's got some old information here, but I'm going to change this. I'm going to point it towards our Raspberry Pi. Now here, we did create a user for this. So I want to say use login. I'm going to set the user to be IPTV. And I'm going to set the password to be the same. And then I can hit next. Now for this particular application, it needs a special authentication type to be enabled in TVHeadEnd, and it's aiming us towards that here. So we'll need to flip back to our TVHeadEnd configuration and sort that out. So it's saying we need to go to the Configuration tab, General, Base, and then Authentication type, which is just down here. You can see it's currently set to Digest. I need to drop that down and then say allow both plain and digest. Then I can save that. And we should, after that, be able to use our Dream TV player okay. I'm going to close that, hit next again, and this time it's been able to succeed. So I can just hit next again. You can see here it shows us the bouquet that we've got configured. So I just want to leave that checked and hit next. I do want to see channel logos in the EPG and any icons. So then I just hit start. It'll update all of its list of icons. And then I can just hit OK. Now the free version of Dream TV Player will only give you up to 5 channels. So you need to purchase it in order to be able to view all of the channels you want. Now I've done that, which is why I've got Dream Player TV Premium here. Now if I go to timeline, then I can see all of my EPG and I can just start playing anything that I want to. And you can see that playing there. And again, I'll get rid of that just because I don't want any issues with copyright. Now the other thing you can do with this app that I've not been able to get working in Tivimate is the DVR functionality. So let's say I wanted to record Garden Rescue here. I could just click on it and hit record. And then that will schedule it up to be recorded. And indeed, if I switch back to my Pi terminal here, I'm doing a periodic directory listing of my recordings folder. And you can see here that that Garden Rescue episode is currently being recorded and written to that location. So once that recording is complete, I can come back and watch it again. Now it's very possible that in Tivimate you can do all of this recording functionality. I've just not been able to get it working particularly well. Maybe it is just a limitation of the fact that it's the free version of the software. But what I really like about Dream TV Player is that it doesn't cost very much and you only need a single license to cover all of your installations through the house. So I find it pretty good value for money. And so there you go, your very own IPTV system. And I can use this to watch my TV services in any room in the house. All I need is a Raspberry Pi configured to run Android TV, one of those 2 applications that I can use to connect to my IPTV services, plug it into the TV, and I'm away. Now this hasn't been the easiest project to set up. You can tell that TVHEADEND doesn't have the nicest UI in the world. However, once it's all set up, it does run really, really well. And also, even though this video has been very, very focused on UK satellite TV, it's relevant for both satellite TV and terrestrial digital TV anywhere in the world. You just need appropriate hardware to act as a tuner and the TVHEADEND software that you can run on any Raspberry Pi. So I hope you'll have no trouble setting it all up for your own use. But that's it for this video. Once again, if you like what you saw here, please click that thumbs up button and subscribe if you want to see more. And also hit that notification bell so you can be told when I put out another video. Please let me know how you get on with this project in the comments section if you give it a go. And again, if you have any ideas for other projects that you'd like to see me have a go at in the future, put those in there as well. Thanks so much for watching till the end, and until next time, bye for now.